Okay, we're going to start looking at possibilities for triangles, because not any three segments are going to form a triangle necessarily, and we want to know when they do and when they don't, and what it kind of means when you do have a triangle, how sides relate to angles and things like that. So we're going to look at just the side and angle relationships first. If you can notice in the triangle that I have here, angle B here is going to be my biggest angle. Okay, it's going to have the biggest number of degrees if I measure it. And right across from B is the longest side. Okay, if I look at angle A is my smallest angle. And across from angle A is the smallest side. Okay, so opposite of angle A is the shortest side. C is kind of the angle that's in the middle, and it's across from the side that's the middle length. Okay, and that's always going to be true for triangles, because if you've got a large angle, that's spreading the sides apart. So it's going to take a longer side to connect the endpoints of those two sides. So the longest side is always opposite, which means across from the largest angle. Okay, and you could replace the word longest and largest with shortest and smallest, or middle and middle. Okay, so the smallest side is opposite the smallest angle. The middle side is opposite the middle angle. Next thing we want to look at is what side lengths allow us to make a triangle. Because if you notice here, I've got three segments, and they don't form a triangle together. So we want to know when they will. Okay, and the important thing here is if I lay these flat, okay, these two sides here, if the red and the blue sides end up being the exact same length as the black side, it's only going to be enough to do this, to have the three sides all laying on top of each other. In order to make a triangle, I'm going to have to bring this side up a little bit. So it's going to have to be just a little bit longer. Okay, so these two sides, the two shorter sides, are going to have to be at least a little bit longer than the biggest side. If they're not longer, here they're equaling the third side. And if I raise them up at all, I'm not going to have a triangle because those sides aren't going to end up meeting. Okay, so in order to actually make a triangle, these two sides are going to have to add up to something bigger than the large side. So written out, the length of two sides of a triangle must add up to be greater than the length of the last side. Okay, so in order to make a triangle, we have to have, if I take any two sides that I have, they always have to add up to be longer than the last side. Usually, I mean, the limiting factor here is what do the two smaller sides add up to? If the two smaller sides don't add up to be bigger than the longest side, then it's not going to be a triangle. We don't really have to concern ourselves with taking the long side and another side and adding them up and make sure those two add up to be bigger than like the middle side. So I'll show you what I mean by that down here. So here, it'd be silly for me to add up 7 and 11 and see if that's bigger than 5. Because both of these alone are bigger than 5. So added together, they'll definitely be bigger than 5. The one I have to worry about is, are these two shorter sides going to add up to be bigger than the long side? Well, 5 plus 7 is 12, and that is bigger than 11. So yes, this would definitely form a triangle. Here, I'm going to look at 8 and 19. Those add up to be 27. Now, that is not bigger than the third side. It's equal to the third side. And that's the case up here where we would only have enough to have our lines equal the third side. Okay, and if I pick these up and keep them the same length, they wouldn't quite meet. Okay, they're not long enough if they're equal. So no, this one would not form a triangle. It has to be strictly larger than the third side. When you add the two smaller sides, it has to be larger. It can't be equal to. It has to be bigger. If we look here, 5 and 5 is 10. And that is not bigger than 13. It's not even close. So this one's no also. Okay, I can give a representation of that up here. Okay, that would be, if this black line is 13, we'll probably say that's about 5 there. Okay, so I'd have 5, and then I'd have another 5. And those are not going to meet. No matter what angles I put in here, they're not going to meet. Even if I have the smallest angle possible, which is none, they wouldn't meet. So in order to make triangles, you have to have the two small sides add up to be larger than the third side. So we can use this to help us find possible lengths of a third side. So if we only know 2 lengths of a triangle and we want to know the possibilities for that third side, there's 2 cases here. So right now I know one side is 8 centimeters and one is 15. That third side could either be one of these smaller sides, okay, which would mean that 8 plus the missing side, we'll call it B, would have to be bigger than 15. Or the missing side could be the largest side, in which case 8 plus 15 would have to be larger than that large side. Okay, so let's look at our 2 cases here. So if our missing side is one of the shorter sides, I can solve this inequality. I can just subtract 8, and I would know that B has to be greater than 7. Over here, if I simplify this, I'm going to get that B has to be smaller than 23. So I now have a range of values. Okay, it can be any number that's greater than 7. Okay, so it's got to be bigger than 7, but it's got to be less than 23. So let's do one more like that. So I've got one side that's 20 meters and one side that's 14 meters. And I want to know what the last side is. Well, again, let's pretend it's one of the shorter sides. Well, then the short side plus the missing short side has to be larger than the long side. Okay, this is our triangle inequality theorem. Okay, which if I subtract 14 here, that means that B has to be larger than 6. Okay, because if it's equal to 6, I'd have 20, which isn't greater than 20. If it's something smaller than 6, I'd have 14 plus 4 or 5 or something like that. And that's not going to be larger than 20. So it's got to be bigger than 6. So it could be 6.1, 6.2. It could be 7, 8, 9, 10. Okay? Now to find out what the maximum size of it could be, I have to assume that it's the largest side. If it's the largest side, these 2 smaller sides have to add up to be larger than the large side, which means it has to be smaller than 34. So B could be any number that's between 6 and 34. So let's write that in one inequality. Okay, and that would be the range of values that would make a triangle. Any value that's outside of there is going to prevent our triangle from meeting and actually being a closed figure or being a real triangle. It's going to be an open shape.